Good morning, all. My name is Deepthi. I am an associate professor in physics, Department of Applied Sciences and Humanities, SESI Institute of Technology and Engineering. Today, I am here to discuss about a ruby laser. It is a first solid-state laser. It was discovered by Myman in 1960, and it is also a three-level laser system and also a solid-state laser. Here we use the ruby rod for our gain, that is nothing but for laser output. For every laser we know that it will consist of mainly three parts, that is active medium, a resonating cavity and a pumping source. Here first I want to discuss about the active medium. Here active medium is a combination of aluminum oxide 99% and chromium 0.05%. Here but chromium will act as an major active to produce the laser output. When coming to the pumping source, here we use a helical flash tube. This is filled with the xenon. This ruby crystal inside xenon flash tube is placed inside the ruby crystal. Now, when coming to the optical resonating system, here we mainly filled with ends are completely solid, completely silvered surface, while the other one is partially silvered surface. These two surfaces will act as a resonating system. Now, when coming to the working system, we have three level. This is a three level, as we discussed earlier. This is a three-level laser system, E1, E2, and E3, where E1 will act as a ground state, E3 will act as an excited state, and E2 will act as an metastable state. So, first of all, by the absorption process, these electrons will pump onto the excited state, which where E3, this E3 will act as an excited state. Here, after completing its lifetime, that is 10 power minus 8 seconds, it falls onto a metastable state. Here, at this metastable state, these chromium atoms, as they lose their part of energy, because it will interact with the crystal and they will decay to the metastable state. Here, at metastable state, the lifetime of an E2 is 10 power minus 6 seconds, as it is more when compared to the higher excited states. These atoms will be going on increasing, where we achieve population inversion. The population inversion is the definition of population inversion. The ground state atoms are less when compared to the higher excited state. So at this E2, where we are getting more number of atoms continuously from the excited state, population inversion will be achieved at the metastable state. So at this metastable state, we have an polished mirrors, that is one is partially reflecting surface, the other is fully reflecting surface. So when all the chromium atoms, when it falls onto a metastable state, these will fully reflect to and fro between the mirror surface, so that the process of complete until the laser action is complete, it will move to and fro between the polished surfaces. So until we get the desired output of 6928, these will move to and fro between the polished silver surface and partially reflecting surfaces. So this causes the stimulated emission, and also it will give an amplification of the light. This amplification will give the desired output, and the remaining atoms which are failed to stimulate, these will fall onto a ground state by giving a spontaneous emission. So the advantages of this ruby laser is we have it is easy and also less cost, and also it has a low output power, so it can be easily used by the children also. These was used in schools and colleges for any science exhibitions, and it also used as a decoration piece. Whereas coming to the disadvantages, the ruby laser efficiency is very less when compared to the other lasers, because it is an optical cavity of the ruby laser is very short, and it is also pulsed laser. So this is called as we say it as a disadvantage for this laser output. So thank you one and all for giving me this opportunity. Thank you.